Right, final words on storage is I've been talking a little bit about partitions every now and again. What a partition is that it's the kind of unit of storage, the unit of guaranteed locality. So each partition can, but is not necessarily served from a different storage node. So each blob is itself a partition. So blobs are not guaranteed to be local to each other, even if they're in the same container. For tables, I talked about it, so the table name and the partition key are its partition. So if you have the same partition key in the same table, it is guaranteed that all those entities are going to be in the same storage node, going to be local to each other. All messages in a single queue are also in a partition. Why would you actually care about this? Is because this is what scales. So partitions are your throughput. If you need more throughput, you need to make sure that they are on separate partitions. So the idea is that they're aiming to get about 60 megabits or megabytes, can't remember, per second out of a partition, or 500 transactions per second. If you need to go more than that, you need to be aware that your queue is going to max out, or your number of transactions in your table partition is going to max out. So that's why you need to know about partitions, at least to be aware of them if you start experiencing limits. If you want more than 100 terabytes, you need more than one storage account. And if you want to do more than 5,000 entities in a second, again, you need multiple storage accounts. And they're aiming at 3 gigabits per second bandwidth per storage account. So these are all the hard limits that are built into the system to try and stop people from just going mental and affecting other people in the multi-tenancy system.